welcome to class.
Shut her down.
Today we're talking fire suppression systems.
Let me know when it's dry.
This appears to be a high extension foam system going off, and we'll get to it. But first, let's talk documentation. First, construction documents. So go into the notes page number 2, so the general notes page of the drawings. Fire suppression, fire protection division 21 is a deferred submittal. So what does that mean? I'm bringing up a DFCM project here, and their set of drawings. You can see all the stuff that they've done deferred submittals on. And what is a deferred submittal? Well, it's design that has to be done in accordance with code, still submitted to the jurisdiction, and that design, when I say design, it might have some level of design done, but the actual calculations or engineering, something like that, is not completed, and so it's on the contractor to finish the design, submit it, and then incorporate that into the construction documents. So this fire suppression, fire alarm, fire protection in this mode, Division 21. So fire suppression. See, I don't know why they called it Division 21 fire protection. Anyways, fire suppression, Division 21 is what I had in my head for Division 21. So that's not using the 16 divisions. That's using master format. I forget how many dang divisions there are. There's a lot. So first thing is understanding that the fire suppression documents, and a lot of times the fire alarm, it's really common to see them deferred submittals. And so what could be the easiest thing of a deferred submittal would be this guy right here, where we have one page of documents with some general notes. This is called the riser, and then you can see all the piping and stuff in this single family home. It's 2 stories, and we've got this as a deferred submittal that went to the city for review. The contractor had to hire a subcontractor that could both design and build that, so they become like a design build subcontractor. In fact, the general contractor owns the design in this, so if there's an error, you're not going back to the designer of record for the project, like the architect or civil, going back to yourself, because the general contractor hired somebody to do the design and the install, or separate that and hire somebody to do the design and then hire somebody to do the install. So it could be done either way. Now, going back to the process for deferred submittals, we think of that stuff all the way back into early planning of the project and estimating. You're gonna have to look at this list and invite subcontractors to participate, and especially write scopes of work and make sure that their contract reads that they have designed, as well as making sure that they have the insurance stuff associated with the design. So design insurance. So we need to make sure that from fire suppression you would think of it being one of the rough activities, but it really starts underground. So the pipe going to the building the civil pipe is usually ending 5 feet outside of the building, And so the water supply to the building on a commercial building is pretty common to see it. And on the civil side, 5 feet out. And usually it's going either through the foundation wall or underneath the footings. And it's usually pretty deep. So the fire, at least in Utah, the water is usually pretty deep. And so it's one of the early things that has to be procured from a contract standpoint, and as well as designed so that you can have that design work done, and that all that can be done relative. Compare that with say like the drain waste vent or hot or cold water piping or something like that. Typically those things are already designed inside the mechanical designer included in the plumbing drawings and the mechanical drawings, and the contractor's just going to get that all organized and installed, and it's not that big of a deal to get that rough piping there. Where when it comes to fire protection, fire suppression systems, and their deferred submittals, it's more work just to get them the riser, and I'll go through it in a second. The riser down below, uh, the water, the feed, and the riser, and then also get that design done so we could have material fabricated or material procured and be on site ready for rough. And what's the sequence for above the ceiling? So sprinklers are above the ceiling, and they are at the top of the ceiling. So let me bring up the BIM model. We're looking at just an office building. I think it's like 3 or 4 stories, maybe 5. Let's see, 1, 2, 3, 4. I think it's about 4 or 5 stories. Let's just get in here so we can talk visually. So as we look at the work, and the sprinklers aren't shown in here, but we're going to, because sprinkler piping is almost always up high connected to uh, the structure above, and then it's usually brought down with drops, sprinkler drops. It's usually one of the first things that gets installed. And so when I don't know what this is. Let's see if we can trace this piping through. I was really just trying to use the model as a way to show how high the oh, no idea what that is. Um, let's see if we can select it and see what it shows. See, it's insulated, so I'm thinking it's in the model. I don't think they put the sprinkler pipe in. I'm thinking that's like, let's see, it's insulated, so it's not the sprinkler pipe. Something else. But the point being that the sprinkler pipe would be up high. So if we're working high to low, and we have this ductwork right here, this big pieces of ductwork getting installed, we'd want the sprinkler pipe in above that, most likely. Or maybe we need to coordinate it and just figure out where it is and put it in sequence. But you're typically going high to low and above ceiling sequence. And so we would be fine if we had sprinklers above this, but I'm not sure exactly where they would be if it was this high. Maybe they are down below it. So in that case, sprinkler would be probably not higher than that duct, or else it'd be penetrating these beams all over the place. So, but anyways, it's something to be coordinated, and a lot of times it's up high is the point. And it's a deferred submittal, so it's something you have to pay attention to. Now, let me actually bring the model back up. Now, during construction, I want to go walk around. Oh, here it is. It's been a while. So as we look at the construction of this building right here, it's a non-combustible construction. It's a core and shell, so I'm not so sure what the requirements would be from the the local fire marshal to have something ready so that they can combat a fire during construction. But on projects where they're multifamily and they're made of wood, it is super common. And in fact, I would see that it would be. Sorry, got a text that was funny. Anyways, so the if this was a wood structure, and usually you can't go very far in the wood structure without having something from the city, not the city, but the fire marshal saying this is, they'll stop you, they'll pull your permit if you don't have some way of getting water to the structure. And a lot of times in these buildings, let's see if we can find it in here. Let's go find the stairwell. We were in the stairs, but I don't see us doing any work on the model to show the sprinkler pipe in the stairwell. But almost always the sprinkler pipe, not always, I mean it could be anywhere, but the point being, the let's try this stairwell over here. Nope. A lot of times you'll see this space right here in a commercial building on the taking up space where they'll put the fire riser, the fire stand going through the floors, going be taking that space right here, or let's see if we can turn it around, see if we can see it on the other side. Oh, where am I? Yeah, I don't see it anywhere. Anyways, a lot of times you go take a look at any building, and a lot of times they'll take this space right here in the corner for that pipe going between the floors for fire suppression. And now during construction, that pipe usually has to be installed, and usually working it out with the fire marshal is they'll want that pipe going all the way to every single floor with a fire department connection at each stair level, and at least one, sometimes multiple parts of the building have to have that in it. And I've never seen it where we do a wood structure without that being an issue where the fire marshal wants to be able to combat a fire if there's a way to do it. And from a contractor standpoint, that's a fantastic thing. If they're going to fight a fire for us and we don't lose the entire building in a fire, the it would be good. So to have that in there, right? Okay. So the next thing, the there is, let's just jump all the way to testing. There's a lot of different tests on fire suppression, but the main one to get past a point of one of the first ones is just a pressure test. And so piping can be filled with, let's just go out here and let's pretend like that is fire suppression pipe, but it's not. It looks like mechanical piping to me. And so, but we would put a pressure test on this, and sometimes it's air, sometimes it's filled with water and then compressed with air to fill it up. But I really like having this pipe under pressure during construction. So if we get to a point where this is completed and they do a pressure test on it, I usually ask them to leave the pressure test on And what that indicates is that somebody hit it with a sprinkler, with a like a scissor lift or something like that. If you walk by the gauges every single day, you see, oh no, we just lost pressure. Somebody just hit that or did something to it, and kind of know roughly where everybody's working in that time, and so you'd know where it was sort of broken or where it got affected. Not that it should be, but it's a good thing to have on there at all. I like having it on there, the pressure test during construction. But one thing, if it is filled with water, one thing I would probably ask not probably, I would recommend having the fire suppression guy, the sprinkler contractor, shut off the supply water to it. And so if somebody did accidentally hit a head or uh, went into a pipe and broke it, it wouldn't flood the entire project. But at some point in time, I'd probably switch that mentality and go, no, I do want to be live. I do want to protect the entire building. And so if we're tested out to some degree and have fire alarm monitoring as well, and that was all going, I would definitely go live, even though we might not have uh, the entire the entire building all signed off by like certificate of occupancy. If enough work was done in the place, I would protect the building. Would be my preference. So coming to testing again, this fire suppression system is one of the main. I mean, it's life safety. So this is huge as far as what we need to do with with our certificate of occupancy. This will be big to get the fire marshal to sign this off and have them sign off saying that this is ready for occupancy as well as all the other code stuff. But fire suppression, fire alarm, they're main part of life safety. So planning that with both getting it in the schedule and then planning it with the subs, as well as getting conversation going with the fire marshal on what they want to see. Because hate to say it, but the different jurisdictions and different fire marshals sometimes want to see different things. And I don't think there's anything wrong with a local fire marshal saying that this is what they wanted to see. They know what they need to do and know their area really well. So, but definitely, I would get in contact with the fire marshal and ask them early on, maybe right into rough, invite them out, have them start looking at things. They'll definitely be there when we do pressure testing as well as some final testing. But getting them involved and understanding what percent they want to see as far as devices, fire alarm kind of jumping back and forth between fire alarm and fire suppression. But uh, those two systems are really quite integrated, obviously. So um, have to kind of treat them as one sometimes. But getting with the fire marshal is a good thing. And now the this is another system that it's there are probably aren't very I can't think of any general contractor type folks that are in a role of project manager or superintendent or something like that came from a fire suppression background. I've seen folks come into the role of general contractor from an electrical background and know a lot about fire alarm, but it's pretty uncommon to have a sprinkler guy that I can think of. I can't think of anybody. I can think lots of different trades, folks moving from their trade into a general contractor role, uh, but uh, uh, but I can't think of anybody in fire suppression. But what that also lends to is it's not super complicated, the fire suppression system, but it's complicated enough that I feel like people ignore it and don't want to learn it or don't take the time to learn it. And so let's look at Wikipedia for a few different. In fact, uh, one of these classes is at Weber State and the book at Weber State, I don't even think covers fire suppression in the book for MEP. But it's definitely an important part of the project, and I don't know why. Maybe it does, and I just missed what chapter it was. So I'm going to go to Wikipedia to share some stuff, if that's all right. Okay, so this is the list of fire suppression stuff. We have a sprinkler system, and I'm kind of going high level here. So sprinklers, they're wet, right? They have something to do with water, and I'll come back to that in more detail. You have a gas uh, system. You have foam, and that's what I started off with was foam and low expansion, medium, and high expansion. So there's some common types of fire suppression right here with automatic fire suppression systems. And so let's talk the sprinkler system here in more detail. And I'm going to put this link in the in the lecture. But this guy does a really good job of explaining the how different systems work and how you can have, let me see if I can find his. So he explains how the actual head is filled with gas, and so when the temperature, this is the sprinkler head, usually it's upside down, the opposite direction is coming from the ceiling, but you can see it going up like this too. But usually heat changes the pressure of the gas inside this little bulb, and this bulb is holding the valve closed. And so when this little I'm going to call it a bulb, I don't know if that's the right word, but as the gas expands in here due to heat, it breaks and allows water to come through. And so that's the sprinkler head itself. But it doesn't mean that, let's see if we've got, so if in this case, say the sprinkler bulb went off, only one head would typically start spraying water. It's possible that the pressure difference, I've heard, will set off other ones as well, but I don't know if that's true. That's just what I've heard. But I know that theoretically, you hit one sprinkler head goes off due to heat, that's where the water is going to come out. And so, but that isn't true on all systems. So some systems are, well, let's go back to it. So first of all, the pipe in this scenario right here, it could be either filled with water or not filled with water. And so they have systems. Let's see if we can get to it. There we go. This guy is a great video. I think you should watch the whole thing. In fact, I'll make an assignment and give you 10 points if you do it. But they have different valves. Let's see if we can get a good picture of it. So this one's a multi-system, multi-operation. Wish I could find it in this guy's video. Well,
automatically delivers the flow of water to the sprinkler.
all right. So this valve right here, one of them, it could be a dry. So you could be water to this point, and then everything past this could be dry. And so not until the fire alarm, a smoke detector or something like that says go ahead and let water flow, will this actually fill the pipe full of water. And so why would you do that? Well, one option is that the sprinklers are in a location where they could freeze, and so they won't fill those sprinkler pipes with water, and they'll put this deluge valve here, and it'll open up and let water go in. But this is controlled by the fire alarm. Well, it's getting a signal by the fire alarm, but the fire suppression system's controlling it, right? Let's see if we can find another one. Anyway, I'm gonna put it in there to watch this video. But the idea is uh, in a dry system, it could still have what they could do is they could fill these pipes with pressure with air, and so when the bulb hits, when the heat breaks the bulb on on the sprinkler, that pressure drop then sends a signal to the valve, say let water in. Another scenario could be where this is open. All of these sprinkler heads do not have any kind of little bulb in them. They're all open, and the pipe is completely dry. And then the fire alarm system, smoke detector, or some flame detector or something, or a combination of multiple of them, indicate that there's a fire in the space. And so then that deluge valve opens up and sends water, and this entire area just will get completely saturated because none of the sprinkler heads are full of water. I mean, none of the sprinkler heads have the bulb. They would all be letting water out. So there's lots of different ways. Let me go back to Wikipedia. Let's see if we. I wonder if I had it here. We had like the terms pre-action. Let's see if they have it here. Here we go. Dry type systems, wet pipe systems with antifreeze. So you have the wet pipe system, you have the wet pipe with antifreeze, and that's usually, I see that a lot when the sprinkler is wet, but then they put piping like up in the attic or something like that, and they'll just fill that section of pipe with antifreeze. As well as, and antifreeze is not just straight antifreeze, it would be water in it as well. And you have the dry pipe system that we were just talking about, where they're either filled with air, and then the little bulb gets broken, and uh, then that pressure drop indicates, hey, okay, I need water on that control valve. And the control valve opens up, send water to it, and then you have the deluge system. So getting into that kind of wet pipe sprinkler pre-action, it's yeah, I know that it's hybrid, but I don't know a ton about pre-action. Let me think for a second. Pre-action. I think that's the one. I'll have to read through it, but I'm pretty sure that's the one where it's air, and the like a smoke detector goes off and tells that thing to open up. Now, foam, we just looked at that for a second. Let's see if we can find any. Um, Now, looking at the gaseous type of fire suppression here and what the purpose is. So, if we had a data center or somewhere with, even in small buildings where they have uh, a lot of like control equipment or something like that, um, I think of like the refinery that worked in, had a little control room, maybe even a bank. Um, we could see it in, again, at anywhere where they have data centers and stuff like that. It wouldn't be wet pipe sprinkler, or maybe they would have wet pipe sprinkler, but it might be a secondary system. A lot of times they'll do the fire suppression with the gaseous fire suppression system. And so let's just click on whatever this is, see if it's got. Anyway, the idea is that there's gas uh, getting into the space through the piping. Found a good little website saying another system that's pretty common that I've seen is called FM200, and I don't pretend to know everything about it, but usually this is a pretty good idea. Like you have these storage tanks, and you have a control panel, and you have discharge piping here, and so the monitoring system, the fire detector, is going to the control panel, and the control panel is going to tell these agents to be able to open up a valve here and send the fire protection, um, they call it liquefied compressed gas, but anyway, so that this, what I understand very little about here, like the extinguishing method is saying that FM200 extinguishes a fire primarily through heat absorption that occurs as an agent changes from a liquid to a vapor during discharge. So it's cooling this space rather than removing the oxygen. And I know that some of the why would that be important? Because there might be people in there. You remove all the oxygen, and somebody's gonna die. Anyway, or get really hurt, pass out, not be able to leave. And they list like server rooms, data centers, stuff like that, where this would be the right way to go about it. But the FM200, seen it quite a bit on used, so I thought it'd be a worthwhile thing, just saying, give you a couple little things there. Another part of fire suppression systems that I think is important to at least have some basic understanding that this exists is the actual fire pump. So many buildings the are running just off the city pressure or the municipality's water pressure, but and that water pressure is coming into the building, and if a sprinkler goes off, that's the pressure that it's using to just basically city water, right? The water pressure in the city to go extinguish the fire, or maybe not extinguish it, but to provide suppression. And so but in many buildings they don't have, maybe they're too tall, or maybe the square footage is too much to rely on the actual pressure from the city line. So they'll have this fire pump, and on this one you can see like this diesel engine here, some motor, and you got, looks like the pumps right here. So the point being, this is a pretty large piping, but even on some smaller buildings they have a fire pump, and so going from fire pump, the purpose of the fire pump is to increase the pressure, the water volume and pressure in the piping, so that it could go above what just the city can provide. But usually you have like uh, the city's piping either coming here, or you have a reservoir tank on the outside of the building that's also feeding water to this. So it could be a couple different scenarios there where with the fire pump. They also have something called a jockey pump, and the jockey pump is just keeping the pressure inside the pipe. So the little jockey pump is there. So let me explain a little bit here. The fire pump is usually running off of a pressure drop, that there's monitoring the pressure inside the pipe. And if the pressure drops, why would the pressure drop inside the pipe? Well, the pressure would drop inside the pipe if a sprinkler head broke, and or the little bulb went off because of it heated up right in a fire, and that water in the pipe would go out that orifice there and try and provide suppression for the area, for the space. But then the fire pump would actually start up, and then, because it monitored that pressure drop. But pressure drop is kind of a funky thing sometimes. Like maybe the sprinkler pipe is old, maybe it anyway, there's lots of different reasons why I can think of, like, again, like leaking, or just the backflow preventer not being perfect, but dropping some pressure. And so in order to keep the pressure up but not supply a ton of um, so that you're making sure that this pump doesn't start uh, needlessly, they have this thing called a jockey pump that keeps the pressure in the pipe up, but it wouldn't be enough to provide like a lot of water in the event for a actual fire event and a sprinkler going off. It's just like this aiding the suppression system to be able to stay under pressure so that the fire pump doesn't turn on uh, based off of a pressure drop, and that would be like a false turning on. And these big dang pumps, they're pretty big, and I don't think you want to just sit there and have them cycle on and off. That's why they have the jockey pump to be able to put a little bit more water in the pressurize the system again. Um, so jockey pump is another term. Let's look at a set of drawings here, and all right. So we've used the word riser quite a bit, and let's just look at this for a second. Fire pump schematic. You guys should know what a schematic is now, and then we could read through all the. Let's separate the so we can kind of see what the fire pump. Excuse me. Woo. Okay, number one, we have the 8-inch fire protection water uh, from existing 8-inch loop around the building. So there's an 8-inch water line going around the building, and that is providing the volume of water needed for the building suppression system. Kind of cool. So instead of building a tank, sometimes they'll loop the building with a kind of a larger water line, and that'll work. Okay, number two. What's that? Exterior door for fire pump access. Cannot believe they labeled it, but whatever. Three. OS and Y control valve with supervisory switch for pump. OS and Y control valve. OS and Y. I can't think of what OS and Y is off the top of my head. It's got to be something simple, but I can't think of what it is. Oh, outside screw and yoke. Okay, so it's just a valve. So that's the main shutoff to be able to get this pipe either open or closed. Number four, 6x5 flange eccentric reducer. Here we go, number six, electric motor. Install pump and motor on steel frame permanently grouted to concrete base. There's going to be a concrete base right here with a fire pump on it. You have the electric motor, and then the pump is right here. And so number five is the pump, horizontal split case fire pump driven by electric motor. Fire pump should be rated to provide a minimum pressure boost of 40 psi at a rated flow of 750 gallons per minute. Pretty cool. And then we could read all this stuff, but I don't think it's worthwhile to spend a ton of time. Let's just read through a few of these. We've got check valve, pressure maintenance pump. Let's see. Pump test header number 14. I might show a little what's that about. So in order to test this pump to see how it's working, they'll isolate the valves so that they're not pressurizing the pipe downstream of this test header, and they'll be able to shoot water out of this and be able to measure how much water and see if it's doing 700 GPM. So we've got the controllers over here, 21 and 22. We got the pump controller as 22. Oh, sorry, 21 is the pump controller. 22 is the maintenance pump controller, pressure maintenance. So that's the jockey pump right there. Pretty sure the jockey pump's somewhere on this wall, if my memory's right. But that looks like that's labeled as the 18. The jockey pump. They got the pre-action fire suppression and 19 a wet pipe sprinkler. But I don't see the jockey pump in there. What's 20? Air compressor. Nine. Eight. There it is. That's the pump right there. That's the jockey pump. Number 8. Electric drive pressure maintenance pump. So why do they call it pressure maintenance? That's all it's doing, is maintaining the pressure inside the line so that that pump doesn't go off all the time, get started all the time. Okay, so there's a fire pump. We got a good isometric view of it over here. Controller. What's this one? That one's the test 15. That's the fire department connection here. So if they need to hook up more water, they can hook more water up here and it can go in, feed the rest of the building. If they have like a fire truck show up or something like that and they need to put more water into the building during an event. You got the test header there, got some valve. Lots of isolation valves. There's the fire pump right there. So the water is coming from the outside up right here, immediately come into here, immediately come into there. So this is the pressure maintenance pump, and that's the fire pump. That one's the one doing all the heavy lifting. That one's the one just maintaining the pressure so it doesn't drop. Let's take a look at just a pretty simple fire sprinkler drawing here. So this is fire suppression, fire sprinkler plan, right? And got an open office and a corridor. And for the most part, I think it's using the architect's reflected ceiling plan as their background. So kind of just showing, usually this is showing the reflected ceiling plan, but it doesn't have to. But the pipe for this space is coming in right here, and it's joining with whatever area is over here, C2 or something like that. And so the pipe has been fed from this direction, and it's saying it's 8'6" above the finished floor, this pipe is. And then it hits this right here, and it's going up. And it's 1.5 inches, and it's 2'9". So this one's from this pipe, it goes straight up 2'9", and it's 1 foot below the deck. So it's going to go up and branch both directions. And you can see that right away there's going to be a sprinkler head drop and a sprinkler head drop right there, and one sprinkler head drop over here on this. So how to view this is that you're going this direction and they're telling you the height, and then it changes height of the pipe, and then you're seeing like the sprinkler heads, and it's telling you 1 foot above, 1 foot below deck. And then the sprinkler pipe size change. Notice that this one's labeled at 3" that rise is labeled 1.5 inches, and then this branch is 1 inch. Okay, then we got a branch going off this way, and they've dimensioned some things here for us apparently. So that one's 8'6". Remember, 8'6", 8'6", coming up again. 1.5 inch pipe going up. It's 2'9" long, and then it's transitioning to a 1 inch pipe, and there's your sprinkler head there. Whoops. And they're labeling it again 1 foot below deck. Below deck, what does that mean? Well, if in this case there's another floor above this, so it could be the concrete deck above, or it could be the roof deck, depending on what part of the building this is. And if this is going up, and say this is sloping, let's say this is a low slope roof, they would want this pipe to to follow the slope of the roof. So, and I'm pretty sure that it is pitched, but I don't remember. It's been too long. It doesn't matter. But that's what they're saying. That this is like following the pitch of the roof. Okay. So let's just talk a little bit about logistics and scheduling a little bit. Let me look at my notes here. So you need to decide with the sub doing the fire suppression how they're going to fabricate. Are they going to fabricate off of a BIM model and participate in BIM and then have all this detailed out prior to, and then participate in that process and then prefabricate everything and ship it all with lengths that are just already cut to length, already ready to be assembled on site, minimal assembly on site? Or are they going to do a bunch of cutting of pipe on site? Are they going to do a bunch of threading of pipe on site? And so maybe we could show a little bit of that for a second. Let me find a YouTube video for that. Put this on pause and come back.
To cut the pipe, put the cutter assembly in place over the pipe. You can cut using keep constant pressure on the carriage hand wheel. Power comes included with 3 straight or tapered threads. It is needed to adjust the die head to the proper pipe size. Loosen the size adjusting nut.
All I was trying to find was something that looked like
and slide the cam plate to the proper pipe size setting. Put all the way front.
The point being,
it doesn't quite reach that groove.
There can be a lot of time on site trying to fabricate pipe.
Notice how the die head foot is slowly traveling down.
So it kind of freaking makes a mess, in my opinion, also on the job site. So you gotta find somewhere where there's no way this oil is all going to be contained in one spot and not get drops of oil. So you got to find a place for them to work, fabricate, that kind of stuff. So that's all part of what needs to be done and thought about when not only do you have to do like the typical things like where you're going to store pipe, how you're going to get the pipe to the space. You also have to think a lot about where we're going to get a setup to be able to fabricate, and it's a conversation you need to discuss with the sprinkler guys, how they're going to do it. They're going to fabricate off site, they're going to fabricate on site, how much are they going to fabricate on site, maybe how much are they going to fabricate off site, do they need a space, that kind of stuff. And some things to common if it say it's a project that doesn't have BIM, you're definitely going to want to spend some time coordinating above ceilings. Look at shafts and chases, like as well as stairwells. A lot of times you have sprinklers needing to go somewhere, and there's an electrical panel or something with dedicated space. So some conflicting spaces, and a lot of times you can have. I think by code you can have a sprinkler pipe above. Ooh, I could be wrong. I think I'm wrong. I don't know. I couldn't tell you. But coordinating the location for the civil pipe as well to tie into the riser, that's super critical. Getting that dimension correct and having the civil contractor put that in correctly, and then think about what's going to go first. Is it going to be foundations and we're through the foundation wall with that pipe, or is it the pipe going to be super deep and it's going to be below the foundation? How are we going to do that? Thinking through getting the two, whoever's doing fire alarm and fire suppression, to coordinate together so that they can do monitoring modules as well as however they're going to communicate between the fire alarm and fire suppression equipment. Coordinating panel locations, stuff like that. And then dealing with all the coordination of testing at the end. And the testing at the end could be a lot. I mean, it could be a lot of work to try and get through fire suppression. I know there's a building at Weber State that I helped work on, and that has smoke evac. It has all kinds of fire suppression systems in it, um, as well as a traditional fire alarm system. All that tying into things like the HVAC system, the elevators, the uh, all kinds of communication. So when it comes to fire suppression, fire alarm, there's a lot to coordinate, and I think folks in the field, project managers and superintendents, typically don't come from a general contractor standpoint, don't come from that world, and so it's something they're having to learn, and definitely something that you can speak the language and learn about, and work with those trades to get it all coordinated with. Okay, let me uh, let me go the opposite direction and just look at this little home, and notice that this is also done not by like this is somebody's drawing that's extreme fire protection, who I like a lot. They've been good to us, good to me in the past anyways. They've drawn this up, and so they've got their simple riser diagram. It's a wet riser, and then looking at how that's all feeding, I think that's worthwhile just looking at this real quick. So that's right here, the water coming in, and then you can kind of see their pipe, and they've got this labeled. I don't know, L1, L2. I didn't bother to go look up all their symbols and stuff, what they all mean. Excuse me. But kind of cruising through, you got pipe here, got sprinkler head, sprinkler head, sprinkler head, sprinkler head, right? And then over here, this is the rise up to the main floor. So this is that end of this line is going straight up to the next floor. So it's in the top left hand corner right there through that wall, it looks like. And then it's going to be in the ceiling space here. Going to cruise around, get all these locations for fire suppression. And so some of the last bits of coordination that might need to be discussed in a custom home like this is, look how nicely the layout is with all these spaces. And some of these custom homes, high-end custom homes there, that even some high-end commercial buildings, you really have to spend a lot of time coordinating the location of sprinkler heads so that they look and line up right with say the lighting or whatever material is in the ceiling. However, it's gonna all align there, and figuring that all out in a ceiling can be a lot of fun and a real challenge with the finishes and aesthetics, and seen on some custom homes where some of these lines are completely buried in a false beam, and they just have tremendous craftsmanship to try and hide some of this stuff. So a lot of coordination on the finishes side to coordinate as well. Well, let's end the lecture there. I hope you enjoyed the lecture. I'm gonna get another assignment to go look at YouTube videos and just post them in there. So I just want you to be exposed to fire suppression. Uh, Watch some stuff on YouTube. I'm going to post a couple of them that I really want you to watch, and maybe I'll just do that. Maybe I'll just throw some in there that I really want you to watch, and if you watched them, you get credit. If you said you don't watch it, it's up honor system here, so you just watch them, but it's your choice. Anyway, have a great night. Thanks for participating.